Hello and welcome to Statistics 101. My name is Manny Estabrooks. This is part 1 of a series of 47 videos in the statistics course. We're coming to you from the auditorium or the stadium, and you can see we have a very large audience here. So let's begin. This first video is concerned with the notion of statistics. What is it? And we want to acknowledge here the various people involved in this production. Now, at the very beginning, we want to show you what a data set might be like. Here we have, in Excel, a data set involving statistics relating to male health. We have the male number. This is the ID number, the age, the height, the weight, the waist size, pulse, systolic and diastolic blood pressures, cholesterol, BMI, and so on. And we want to see if there's a pattern in the data here. In particular, we have a similar data set for female health. We want to see if the waist, pulse, and systolic figures involved are the same for male and female. And so what is statistics? At its most specific level, it involves any of the following. It's just the activities associated with sampling, the collection of data, the analysis and interpretation of the data, and the conclusions and presentation of the results. It involves detecting a signal or pattern in what otherwise be random noise, and various statements of alleged facts that are numerical in nature and serve to identify patterns or trends in economic, social, psychological, and physical world. It's used in weather forecasting, rain, snow, sleet, and hail, stock market data, traffic volumes, health statistics involving obesity rates, cancer deaths, and so on, retail sales data, unemployment levels, job loss, job created. Statistics is everywhere, and it's an indispensable tool in today's planning for government agencies as well as businesses adjusting to restructuring or tweaking business activities, individuals in food choices, health-related data, and so on. So we want to look at the various types of data here now. We ask that you pause the video at any time and check out these on Wikipedia. A variable is an aspect or attribute of the phenomenon of interest that exhibits variation in its outcome. It's basically an aspect of the data set that we're looking at. There's qualitative or categorical or nominal variables, and these reflect a quality or non-numeric feature, and examples include gender, male, female, hair color, make of automobile, types of fruit, apples, oranges, telephone numbers. So these are qualitative in the sense they specify a category or named variable with the quality involved. On the other hand, we have quantitative data. It has a measurable or countable feature, and examples include rainfall, heights of basketball players, cancer deaths by region, yields of grain across the region. Now, the quantitative variables can be divided into a continuous variable, which assumes a value on a continuous scale and can be measured to any degree of accuracy depending on the measuring device involved. Examples are heights of people, weights, and so on. Now, a discrete variable is one that assumes a finite number of possible values. Examples might be shoe sizes. There's only a finite number of sizes available, coin denominations, and so on. Now to terminology. We're going to be talking about a population, and we're going to say that a population is the set of all data items of interest or under discussions at a point in time. And from this population, we're going to take a random sample. It's a non-biased representative of the population. It has to be done in a random fashion. As you'll note here, they come from all over the population. And from this, we have a sample, and we come up with the notion of a sample mean, standard deviation, so on. And we wish to make inferences about the population on the basis of this sample. And this is the probability notion or the foundation of inferential statistics. Now we're going to look at some terminology here. A parameter is an aspect of the population, and some examples are the mean with the designation mu, standard deviation sigma, and proportion rho or p, and these all refer to the population. In contrast, we have a statistic which is associated with the sample, and that includes the mean. Note this is x bar, standard deviation S, population proportion. This p hat is like x bar, but it has a little wedge on the top. And we're saying that in statistics, we're going to use the sample data to make inferences about the population and a probability notion. Now, I've taken some documents from the newspaper. Here's some. Obesity, effect on brain matter. Now, you should feel free to pause the screen at any time and read these, but look at the numbers involved here. 40-year-olds, 50-year-olds, 527 individuals, 2087. Now these are statistics. Here's another one, 28%. So these are claims or results of sampling. And finally, the perception. This is psychology. Here's another one, meat isn't deadly, in moderation. And again, we're going to just leave this for you to view on your own. And note the statistics involved and the implications it might have for you and your lifestyle. We're going to suggest that there's several websites you can look at. There's Wikipedia, there's the ask.com, Stats420 blogspot. Generally, if you go into Google and type in the word statistics, you'll get a huge array of material that's on the internet. Well, that brings us to an end of lesson 1. We ask you to review this once again. Take notes as required, and we'll test you in class. Thanks, and have a good day.